Right. Hello, everybody. My name is Alessia, and I am the lead lecturer here at Pearl Street Studio. And welcome to our introductory lecture on coal. So coal is an energy resource that is used around the world to generate electricity. So the goal of this lecture is to help people understand what exactly coal is, how it's used to generate electricity, and discuss some of the considerations around using coal as an energy resource. So let's start by discussing what is coal. Coal is a rock that is formed from the fossilized remains of ancient plants from hundreds of millions of years ago. And if we look at it from a molecular standpoint, it's composed primarily of carbon and hydrogen, but it also has many other elements that are present in its molecules, such as a little bit of oxygen, potentially some nitrogen, sulfur, mercury, lead, arsenic, among many other elements. So it's these large, complex molecules. It doesn't have a singular chemical formulation for it. And so here you can see I've sketched out a coal molecule that was found in a sample of coal to help illustrate just how complex these large and complex these molecules are. All right, let's go into let's talk about how coal is formed. So coal, as I mentioned, is made up from dead plants that existed about 300-ish million years ago. And these plants were living in a swampy environment, and when they died, they sank to the bottom of this swampy marshland. And over the period of hundreds of millions of years, these dead plants accumulated at the bottom of this swampy marshland, and they were covered by dirt, rocks, and sediment. And all of this, dirt, rocks, and sediment, plus the water of the swamp, compressed this dead plant matter into a carbon-rich substance called peat. And over the next 100 million years, this peat was compressed by all this substance above it, but then it was also exposed to the geothermal heat from within the earth to make the coal that we are able to find today. So today this coal is found deep underground, packed under many layers of soil and rocks. And here, let me just label my diagrams here. So if we are looking at this one is supposed to be, this dark brown layer here is supposed to be the peat. This green layer here is supposed to be the dead plants accumulating. This brown part here is supposed to be the sediment. Oops. The sediment. And here's the water. And then if we come to today, here we see this black layer here is the coal. This dark gray layer here, that's the rocks above the coal. This is the dirt, the brown layer is the dirt above, and then you can see a tree and grassland above it. And so today this coal is found packed underground under many layers of soil and rocks. And in the next section the next subsection, we're going to be discussing the ways in which we access this coal through different mining methods. But before we get onto that section, there is a bit of terminology that I wanted to go over first. And the first term that I wanted to go over is a fossil fuel. And because coal is made of ancient fossilized plant matter, it is called a fossil fuel. And a fossil fuel, the definition of it, is a naturally existing hydrocarbon. So a hydrocarbon is just a resource that is made up of mostly hydrogen and carbon. So a hydrocarbon energy resource created from fossilized plants and animals, which is exactly how I've described it here. And then the other term, or set of terms, that I wanted to discuss is the term non-renewable resource and renewable resource. And coal is considered a non-renewable resource because it takes hundreds of millions of years to create new coal reserves. And the definition of a non-renewable resource is an energy resource that has a fixed supply on Earth, and once it's used up, it is considered depleted on a human timescale. And because coal takes millions of years to create, once we use up a coal reserve that we have found, it's going to take a few 100 million years in order for it to be replenished. Now, on the other hand, this is in contrast to a renewable resource. And a renewable resource is an energy resource that is replenished on a human timescale and is almost inexhaustible. An example of this is wind and solar energy, which we're going to discuss in some of the later lectures in this course. But for now, we're going to stick with coal. All right, let's go to how coal is mined. Here we go. So, coal is found in varying geographies across the world, from just below the surface to deep within a mountain. And depending on the location of the coal, there are three main mining methods. So there is strip mining, there's open pit mining, and there is mountaintop mining. So let's start by talking about strip mining. So strip mining is used when the coal seams are located relatively close to the surface, about 30 meters down or about 90 feet. And in strip mining, the vegetation and the top layers of soil and rocks are removed by excavators to expose the coal seam below. So here you see there's some dirt here, and the coal seam is relatively close. Oh, let me change this to green. Is relatively close to the surface. Here you have a little excavator that can get the coal, and then here there are some piles of dirt, rocks, soil, sediment from this mining process. Then the second method is open pit mining, and open pit mining is used when the location of the coal is a bit deeper underground. And so what happens is that the excavators dig in a spiral downwards. And so from the side, it looks like these terraced steps that I've drawn here. But from the top, it looks like this spiral. The excavators are digging down like this. And the terrace steps from the side are just these parts of the spiral. So these are the sides, or the spiral as it's digging down. And here you can see there's an excavator. Here is the coal, and then here's the sediment from the mining process. And then the third method is mountaintop mining, otherwise known as mountaintop removal. And this involves removing the first 300 meters of a mountain, or about 1,000 feet, to expose the coal seams from within the mountain. So you can imagine in this little sketch here, the mountain used to be about that tall, but then miners use TNT typically to explode part of the top of the mountain off, and here you can see the sediment down at the bottom of the mountain. There's a little excavator here, and it's trying to access the coal that is deep within the mountain. All right, now before we move on to the next section, I did want to discuss some of the health and the environmental impacts of coal mining in comparison to some of the other in comparison to some other energy resources, because coal mining has some extra impacts that are not found with other energy resources. And the first one is the worker health impacts. So when mining coal, there is this fine particulate dust particles that are released into the air. And the workers who work in mines that inhale this dust over many years commonly develop a disease called black lung disease. And this disease is where coal dust accumulates in the lungs over many years, and it causes inflammation of the lung tissue and scarring that leads to difficulty breathing. And if a worker is continually exposed to these conditions, it can lead to a permanent disability or premature death. And so this is an impact that is not found across any of the other energy resources. The second major consideration here is deforestation. So since coal needs to be continuously mined to supply fuel to coal-fired power plants, which we're going to be talking about soon, it can lead to widespread deforestation and habitat loss. And this is the case for all of the mining methods, but you can imagine this is especially the case with strip mining. And then the third consideration I wanted to discuss was water pollution. So the loose debris, which here you've seen I've sketched out some of these piles of loose debris. This loose debris, whenever it rains or if there are very strong winds, this debris can be blown, or it can get into local streams and rivers and lakes, and it can physically block the streams with the debris, but it can also contaminate the water with some of the heavy metals that are found in this debris from mining. So there are some pretty serious health and environmental impacts of mining for coal that we don't find when accessing other energy resources. Okay, with that, let's discuss now how burning coal produces energy. So when coal is burned, it undergoes a chemical reaction known as combustion. And combustion refers to a chemical reaction between a fuel and oxygen that releases thermal energy. So in the case of coal, here we go. Here is the coal combustion process that I've sketched out. So the reactants, so what we start with in this reaction is there's the coal, which is a complex carbon chain, as shown up above. And then there's oxygen, which is coming from the air just around. And then when a combustion reaction is ignited with these, with the oxygen and the coal, it releases thermal energy, carbon dioxide, and water. But because coal is not a pure fuel, it has many impurities, such as mercury sulfide, and then there are other various elements that are present in these complex carbon chains. And then the air in the combustion reaction is not just pure oxygen, it also contains nitrogen. So what happens during the combustion reaction? There are actually other chemical reactions that are happening simultaneously with the impurities. And these lead to things such as nitrogen dioxide, sulfur dioxide, and mercury as well. And in the combustion process, what's happening from an energy standpoint is that chemical energy is being converted into thermal energy. And so if we look at the complex carbon chains that make up coal, there are these little black lines, which are the bonds between the atoms within the molecule. And these bonds contain energy. And when these bonds are broken in the combustion process, where all these atoms are rearranging themselves to make these various other molecules, some of the energy that was contained in these bonds is released as thermal energy. And this thermal energy is what coal-fired power plants use to generate electricity. And so here, thermal energy is simply just heat. Heat is its more well-known name. Okay, so that's the coal combustion process. Now let's discuss, or let's walk through, how a coal-fired power plant generates electricity. Okay, so here is a sketch, a simplified sketch of a coal-fired power plant that I've put together here. And let's do some labeling. Okay, so these gray piles here are supposed to be the coal that has been mined. Now the first step in this process is pulverization. And so when coal is mined, it comes out in these big chunks, these big rocks. But it's very hard to burn something when it's in this big chunky form. So the first step is pulverization, where the coal is ground into a powder to make it easier to burn. So this thing here is the pulverizer. And what it does is it crushes the coal into a powder. So this can be labeled as pulverized coal here. Okay. And then the next step is initiating the combustion reaction here. So what happened is this pulverized coal is then dropped into what is called, my screen glitched a little bit, is dropped into what is called a boiler, which is what this is here. So this is a boiler. And what a boiler is that it takes a fuel and it takes some air just from the atmosphere, and it initiates a combustion reaction in order to heat water. Here. Okay. And so you can see in this boiler right here, you can see that there's water coming in and it's being piped through this boiler. And as it's being piped through the boiler, it picks up the thermal energy. The thermal energy is transferred into the water to convert it into steam. And that's the third step. Thermal energy plus water, it leads to steam. So what happens here? Yeah, as the water is piped through, it turns to steam. And then another note here, you can see these are the emissions here. The emissions from the combustion reaction, which includes like the sulfur dioxide, the carbon dioxide, the nitrogen dioxide, etc. That is all comes out of the top of the boiler right there. Okay, so as this water is converted into steam, water actually takes up a much smaller volume than steam. So as it is converted into steam, the steam becomes very high pressure being trapped in these tubes or pipes, and then it is at a very high speed is directed towards this high pressure steam is directed towards what is called a steam turbine. So this here is a steam turbine. And how the steam turbine works as the steam is going towards it here. Let me zoom into my drawing here. So I've put together a simplified sketch of a steam turbine to explain how it works. So you can see here there are these curved blades. So they're not these flat blades. And what happens is that steam is coming towards the steam turbine like this. And when the steam hits these blades, because they're curved, the steam actually gets pushed up a little bit. And as the steam is trying to get through this blade, it's pushed up a little bit. It's also pushing down on these blades. And you can imagine as there is many streams of steam coming towards the steam turbine, it is as these streams of steam are pushing down on these blades, it's actually forcing the turbine to rotate. And so what's happening here is that the thermal energy of the steam is being converted into kinetic energy. And kinetic energy is just the energy from the motion of an object. So a car, for example, has kinetic energy when it's driving on the highway, and you have kinetic energy when you're walking from one location to another. And so here, in this example, the steam is making oops, nope, didn't mean to erase my turbine. The steam is making this turbine rotate here. And this is kinetic energy, but it's also referred to as rotational kinetic energy, which is just instead of something going in linearly in one direction, rotational kinetic energy is something spinning in a circle, which is what the steam turbine is doing here. So that's what happens here. And then you can see that the steam turbine is then connected to this other thing here, which is called a generator. And when the steam turbine is connected to the generator, what happens is that the generator takes the rotational kinetic energy of the turbine and it turns it into electrical energy. Now, it's actually a bit complicated from a technical standpoint how a generator converts rotational kinetic energy into electrical energy. Now, for this course, we're just going to keep that as a black box and just accept that that's how that works. That I think the topic of how a generator does that is for a future, more technical course. But yeah, so that's what happens here. So electrical energy here, this is the energy in charged particles, typically electrons. And in this context, electrical energy is just electricity. So this is what we want as our end product. So if we look at this diagram, we can see here the generator then the electrical energy that is generated from the generator is then transported here in power lines and electrical wires to what is called the, oops, nope, I spelled electric wrong, electric grid here. And what the electric grid is, most simply, is that it's a large interconnection of electrical wires that transport electricity from power plants to consumers, like homes and businesses. So this is the electric grid, is how electricity goes from power plants to your house. It's how you're able to power your laptop or your phone so that you can watch this video. Now, for this unit, we're just gonna stick with the image that the electric grid is just this really, really big interconnection of a bunch of electrical wires. But in our next unit, which is titled Electric Grid Planning and Management, we're going to go over in more detail what the electric grid is and discuss more of the components. But for now, we'll just keep this idea of the electric grid as the simplified example. Now, all right, we're going to take a bit of a step back, and we're going to take a look at the bigger picture. So we now understand how a coal-fired power plant works. We understand where coal is from, the combustion process. Now I want to answer some of the questions like, how much does it cost to build a coal-fired power plant? And how does coal get from the mines to the power plant? So I've done this in a section called, what are the operational characteristics of a coal-fired power plant? So the first, this first one, the controllability of a coal-fired power plant is that it is a dispatchable unit. And what a dispatchable resource or generation resource is that it's an electricity generation resource that has a controllable output. So operators can control how much electricity is being generated by this unit. And this is in contrast to some other resources that are not controllable, but we'll be talking about those later in the unit. For now, we're going to be sticking with coal-fired power plants. Okay. Next is the fuel supply chain. So when coal is originally at the mine. It's mined by these little excavators. And then from there, the coal is loaded onto trucks and trains, where it then can be delivered to coal-fired power plants. But these coal-fired power plants are not necessarily on the same landmass as the coal mine itself. For example, Australia is a country that that mines a lot of coal, and they actually export a lot of coal. But Australia itself is surrounded by water. So the coal has to be transported in other means other than trucks and trains. And one example is that Australia actually exports a lot of coal to India. So let's say instead of Australia burning coal locally within the country, they want to ship some of their coal to India. So what happens is from the coal mine, that coal is loaded onto trucks and trains. It is then brought to a port where the coal is then loaded on a ship. It is that ship then goes across the ocean to a port in India where it is then, the coal is then unloaded on trucks and trains, which then can deliver that coal to coal-fired power plants, in this example, India. Okay. Next part, fuel storage. So, coal-fired power plants are able to store coal on site, so that they can continue to generate electricity even in the event of some supply chain disruption. So let's say there is a really severe weather event or there's a natural disaster that temporarily stops trucks and trains from reaching the coal-fired power plant. Because it's very easy to store coal on site, just in large containers. This allows coal-fired power plants to continue to generate electricity with the coal reserves that are on site, even during some of these disruptions. And this means that the power plants are resilient to short-term supply chain disruptions. Okay. The next thing that I wanted to go over is capital costs. Now, if you've never heard of the term capital cost, that's okay. Capital cost is just the term described for the cost to build something. So how much does it cost to build out a coal-fired power plant? And even though this section is about the operational characteristics of a coal-fired power plant, it is important to understand how much it costs to build out a power plant, because these costs need to be recovered throughout the lifetime of the power plant. And so, to explain the capital cost for coal-fired power plants, we're going to be introducing this new unit called a megawatt. And a megawatt is notated through a capital M and a capital W. And what it is, it's just the rate of electricity that can be generated by a power plant. And the megawatt rating is of a power plant is the maximum rate at which the power plant can generate electricity. So the higher the megawatt rating of a power plant, the more electricity it can generate at any given moment. And so a very, very large power plant is going to have a big megawatt rating, and a small power plant will have a smaller megawatt rating. Now, I know you guys don't have an intuitive idea of what exactly a megawatt is, what is it equivalent to, but for now we're just going to be using it as a comparison between different energy resources covered in this unit. And then in the next unit, we're going to be giving a more intuitive idea of what exactly, like how much is a megawatt. But I thought probably the most boring way to start a course would be to start by introducing units. And just understanding that megawatt is a rate of electricity generation, I think is good enough for now. So in the this data I got from a US report. So this is in US dollars from 2022. It cost about $4.5 million per megawatt in the United States to build out a coal-fired power plant. And the typical size of these power plants is about 200 to 1,000 megawatts. So this means that on the smaller side, or a coal-fired power plant on the smaller side costs about 900 million to build out. And then one of these larger power plants that's at 1,000 megawatts, it costs at about 4.5 billion US dollars to build out. So these are very large power plants. Okay. The next thing I wanted to go over was the operational costs. So once the power plant is built, it's going to still cost money to operate the power plant. And this includes things such as the fuel itself, so the coal. This includes paying the operators to operate the power plant, as well as maintenance to replace parts when things break or wear out. And I'm also going to be introducing this other new unit called a megawatt hour, which is notated by a capital M, a capital W, and a lowercase h. And a megawatt hour is an amount of electricity. So megawatt is the rate of electricity that can be generated, and a megawatt hour is the total amount of electricity. So I think a pretty helpful analogy here is that the megawatt rating of a power plant is like the maximum speed of a car, so the fastest this car can go. And in this analogy, a megawatt hour is like the total distance the car can drive over a period of time. So if you have a more powerful car with a higher max speed, this car can drive a larger distance over a given period of time. Now with a power plant, the higher megawatt rating of a power plant, the more electricity it can generate in megawatt hours over a given period of time. So that's kind of the analogy I have here. And so operational costs are described in dollars per megawatt hour. So how much does it cost per amount of electricity, or how much does it cost to generate a unit of electricity? So here, this value here is in a little bit different years here, but it's in US dollars in 2026, and it costs about $30 to $45 per megawatt hour, depending on the coal-fired power plant. Okay. I know these numbers kind of they don't really mean much to you, but they're going to be useful for a comparison with other resources later in this unit. All right, now let's go to pollutants and emissions. So the products of coal combustion can generally be put into one of two categories, either air pollutants or greenhouse gas emissions. And air pollutants, the definition of an air pollutant, if you're not familiar with it, is particulate matter or gases that can contaminate the air that we breathe, that can harm humans and the environment. So it's toxic. On the other hand, a greenhouse gas is not necessarily immediately toxic, but at a large volume, greenhouse gases can trap heat within the Earth's atmosphere. And so here with coal, some of the air pollutants are sulfur dioxide, nitrogen oxides, mercury, and particulate matter. And some of the health impacts of these are like smog, and they can cause asthma and cardiovascular diseases, but I'm not going to go into too many of those details here. The exact health impacts of these are going to be discussed in more detail in Unit 4 of this course, Environmental and Social Impacts. And then for greenhouse gas emissions, carbon dioxide, methane, and nitrous oxide are the greenhouse gas emissions that are typically emitted from coal-fired power plants. Now, this might beg the question, why do we care about greenhouse gases if they are not toxic to us? Like, you can breathe in carbon dioxide and you're still perfectly fine. The thing is that if enough greenhouse gases are spewed into the atmosphere, they can lead to what is called climate change. And climate change is a long-term change in global and regional weather patterns. And since greenhouse gases trap heat within the Earth's atmosphere, a lot of greenhouse gases can lead to an average temperature rise on Earth. And this is actually something that we are currently experiencing now. And the thing is that this temperature rise that we are experiencing across the globe is caused by human activities over the past century that have spewed a lot of greenhouse gases into the atmosphere, but we're really starting to see the average temperature increase. And the climate change that we are experiencing right now is sometimes referred to as anthropogenic climate change. And this is just climate change that is caused by human activities. In this case, the release of greenhouse gases from combusting fossil fuels such as coal. So this is an important note to keep in mind that we're going to be referencing in other lectures as well. Okay, and then the last part of this section is the role on the electric grid. So how are coal-fired power plants operated? And when I say role on the electric grid, I am describing under what conditions and over what time period is this type of power plant used to generate electricity. So that's a lot of words that maybe didn't make sense to you. But let me try to explain it in more simpler terms. So coal-fired power plants, they're these very huge power plants. They can typically take a couple hours to adjust the rate of electricity that they are outputting. And so because they take a while to change their output, they are typically just operated at a constant rate throughout the day. And this is what I've drawn here in this little graph, chart, diagram, whatever, here. So the x-axis here is the time of day. So here I have 6 a.m., I've got noon, I've got 8 p.m. And then the y-axis here is the rate of electricity either being demanded by consumers like us or the rate of electricity being generated by power plants. And so this blue line here, which I'm highlighting in my blue highlighter, is an example of electricity being demanded, the rate of electricity being demanded by consumers throughout the day. So in the evenings, it's expected that the electricity consumption is lower because people are turning off their lights, they're going to bed. But in the afternoons and in the mornings, there tends to be more electricity being demanded because people are waking up, they're turning on their coffee machines, they're turning on the lights, they're turning on the TV, etc. So there's this increase in electricity being demanded. But then this purple line here represents how coal-fired power plants are operated. And so they're operated to output the same amount of electricity, or the rate they're operated to be generating electricity at the same rate throughout the day. And resources that produce electricity at the same rate throughout the day are called base load resources. And so a base load resource is a dispatchable resource that typically requires hours to adjust the rate of generation. So it is typically run constantly throughout the day. So for 24 hours a day, it's just outputting the same amount of electricity. Now you see that there's this delta here, this difference between what is being demanded by consumers and coal-fired power plants. And this is because there are many other energy resources that are used to provide electricity to consumers. And there are resources that are better managing this variability throughout the day in comparison to coal. But coal-fired power plants do provide a base load resource in many electricity industries, electricity industries around the world. Okay, that's that. Now on to my last section of this lecture. What are the geopolitical considerations around using coal as an energy resource? And the first one is that coal has a diverse fuel supply chain. So coal can be found in many different regions and countries around the world. And this geographic diversity can reduce the dependence on any single country. So even if a country doesn't have their own coal reserves, if they import coal from another country, they can easily switch to sourcing their coal from a different country if, let's say, some geopolitical disruption blocks one country from exporting. So this means that fuel shortages are unlikely to occur, making coal a relatively stable energy resource to rely on for electricity generation. Now, the second geopolitical consideration is what we call energy independence. And as I mentioned, coal is prevalent across the world. So there are many countries that have coal seams that they can mine from. And if countries use nationally mined coal for generating electricity, this can minimize their dependence on other countries or foreign energy resources. So this means that if there are geopolitical tensions, if there are trade embargoes, or if there's a war, countries that utilize their own nationally mined coal will be likely less affected by some of these disruptions. And so this is this term energy independence here. So it's the ability for a region to meet its energy needs, either partially or fully, with domestically sourced resources. And so some of the countries, a couple examples of countries that have partial energy independence from using nationally mined coal are Australia, China, Poland, Kazakhstan, and South Africa. So if you're interested in learning more about that, you can look into those countries. Now, the third consideration is transboundary air pollution. So one of the unfortunate things about coal is that the wind can blow air pollutants across borders from coal-fired power plants, and waterways can spread the debris and the pollutants from coal mines to downstream regions. And what this means is that it results in countries bearing the burden of coal pollution while not gaining the benefit of electricity that has been produced from the coal. And this is a somewhat contentious issue in Southeast Asia, for example. Okay, and then the fourth and final consideration here is the disproportionate impacts of climate change. So burning coal is responsible for about 30% of the greenhouse gas emissions that are emitted globally. And regions like Europe and North America have been large contributors to greenhouse gas emissions into the atmosphere over the past 100 years or so. But Europe and North America are projected to be less impacted by climate change. Keyword less here. Less impacted in comparison to regions such as Sub-Saharan Africa, the Middle East, Southeast Asia, and island nations. And in relation, these regions have contributed less to greenhouse gas emissions over the past century in comparison to North America and Europe. Oh, sorry, I need to take a sip of water there. Lots of talking. Okay. Well, that's it for our coal lecture. Um, Thanks so much for watching. This is the very first version of our coal lecture, and we are sure that there is much to improve here. So we would love your feedback. Do you think that something was not explained clearly enough? Do you think that there is other information that we should have added? If so, we will add a link to a feedback form, and after receiving a sufficient amount of feedback, we will update the lecture, we will re-record, and we will post the updated video. So for those of you who will be providing feedback, thank you so much for helping us to improve the quality of publicly available education. And then also, if you found this lecture, please consider donating to help us continue making publicly available educational content on the electricity industry. We will add a link in the notes, but you can also donate by visiting pearlstreetstudio.org. Okay, well, that is it for our coal lecture, and hope to see you at our next lecture on crude oil.